We are under lockdown. Hey, welcome. Thank you for joining us on our first ever show on AskHowAbout. We've reached up to 3 million cases and we still don't know much about the coronavirus. One of those overnight sensations, pop stars or movie stars who just come up and be like, "Ha, why should I talk to you? I'm too cool for you. I'm hip." Damn right, coronavirus, you are hip, you trending, and you got the tube, not the attitude, the corona tube. Regardless, I'm no expert, and I'm pretty sure people are watching, or rather, people in general are no experts on the virus. So, we call it an expert. The guest we have on today is Dr. Vivek Tanavde. We're pleased to invite him, and he's been a microbiologist by training. He's also been in Bioinformatics Institute for the past 11 years, and he's worked on projects related to it. And also, right now, he is more in tune towards cancer research and stem cell research. Those are his, titles. Here's a title you might not have heard of. Legend says he's supposed to be the father of coffees, but he was born a few hundred years later. So he's perfected the art of coffee, making him the world's first coffeeologist. So here's the interview. Dr. Vivek Tanavde, thank you for joining us and being our first guest on our show. And I hope everyone is safe at home.
Yes, Pranay, thank you for having me on this show. And yes, we are all at home, heeding to the call of stay at home and defeat the virus.
That's everyone's hope. So let's get to it then. So coronavirus, not a secret. It's a virus and it's highly contagious. But I thought let's take a more casual approach in the sense like let's start from the basics.
Hmm.
What is a virus? Why is it so different from other parasites or other organisms we've encountered so far? Because some of
Okay,
the greatest pandemics have always been a virus. And is there any reason
sure,
why?
sure. So, a virus, in its simplest term, is a piece of nucleic acid, DNA or RNA, that is wrapped in a protein envelope. And that's all that it is there to it. So, it's a very small piece of nucleic acid wrapped around with some protein. And what makes the viruses different from all the other infectious agents like bacteria, parasites, etc., are that the virus really has no machinery of its own. So if you think of it, it's like a hijacker. Like we have hijackers that hijack planes. The virus hijacks the human system or the animal system. So it hijacks the cells that it infects, and it kind of makes these cells do what it wants them to do. So it hijacks and the controls. Again, similar to the way in which a hijacker could hijack a plane or two planes and then make them do what they want, including flying them into the World Trade Center. So, in a very similar manner, the virus hijacks the cells that it infects and makes it do whatever it wants. And that makes it extremely dangerous because we really have no means of targeting the virus.
But don't other parasites work the same way as well? Because, for example, even bacteria, so protozoans, even they take control of our body. So, what
Right.
makes this so special?
All right.
And
So,
pertaining to especially the coronavirus.
so the bacteria and parasites also work in a similar manner. They do hijack our system. But then the crucial difference is that these bacteria and parasites have systems of their own. So they have targets that we can hit. So again, think of it as an enemy that is visible versus invisible. So if you have a very deadly enemy that you can see, you have a target. You can try to defeat the enemy by shooting it down. But it becomes a lot more challenging if you can't see the enemy. If the enemy becomes invisible, then you don't really know where the enemy is. You can't see the enemy. And so, in a similar manner, viruses, because they have very little of their own material, and most of the machinery that they used is from the host, we can't really see them, and that makes them extremely dangerous.
So, using your same analogy, like it's an enemy which cannot be seen. A lot of experts have said that there's kind of like a zombie apocalypse, except, like, for example, for movie reference World War Z and stuff like that. But
Mhm.
we cannot see the enemy. So,
Right.
does that add to the mass hysteria which is caused right now all over the world?
I think it does. So I've been wondering about a curfew imposed when there are, for example, riots and people violating the curfew. Well, when that happens, violations happen even then. But it's a lot easier because people look out for the police, they look out for rioters, and if the coast is clear, they can get from point A to point B. People have been trying to utilize a similar strategy now, except now you can't see the enemy. The virus may be in the air. You may be touching it, you may be inhaling it. It's spread through droplets. And so even if the coast is clear, even if the road is empty and there's nobody to see you, and you get from point A to point B, there's still a chance that you may get infected if you come in contact with someone who is already infected. And so it's hard for people to imagine this because we can't see this enemy. Many people do not understand the severity of the problem, or they think that why is everybody asking us to stay at home and nothing, there's no real danger, because if I go out of my society gate, I go out on the street, apart from the fact the streets are empty, everything else is normal. So it's a lot more difficult for people to understand this threat.
Staying on that topic, even this is not the first pandemic we have faced. Going back to 10 years, you must experience this because you were in Singapore with the swine flu. But this is truly taken, and not just the swine flu, even going back towards even the centuries back before centuries, like pandemics have been occurring again and again.
Right.
But what makes this so special that even after so many advancements in medicines, we are still not able to cope up with it?
So it's interesting that people have been studying the parallels between pandemics, including this one. And one of the most cited pandemic is the Spanish flu, influenza pandemic, that still probably ranks first in terms of number of people that died. I think the more people died of the pandemic than they died in the First World War when it happened. And at that time, remember, the world was not interconnected. People were still local. Everything was, we were dependent. You just lived in a village or a city, and everything that you needed came from the village or a city. You were not dependent on bananas grown in Peru, or sugar coming from somewhere, or rice coming from Vietnam. So that's the first difference. Now we live in such a globalized and interconnected world that a disruption to the supply chain is even more dramatic and drastic. The same goes for people. So air travel at that time was not very, very common. There was no air travel. But today, with the prevalence of air travel and just the number of people traveling from one country to another, it is very, very difficult to stop that or to halt that. Last pandemic that the WHO had declared was in 2009. So it was only about 11 years ago. Unfortunately, India was not affected very badly during that pandemic, but a lot of other countries were. And the difference this time versus even compared to 2009, to the influenza or the swine flu pandemic, is that the infectivity of the coronavirus is extremely high. It's very easy for this virus to spread through droplets, through surfaces, and for people to get infected. And that's why this has spread very, very quickly and very, very rapidly. And all it took, for example, there is new epidemiological data coming out that all it took were a couple of people, from one person coming in from China, somebody coming from Italy into the United States. And within months, there are now 800,000 plus infection. So it is, the speed at which this infection has spread is truly, truly alarming. And that is, I think, what makes this one, this pandemic different than the others that have happened before.
So you can say that it's a combination of factors of how today's lifestyle and the contagiosity of the virus causes this to
Yes.
be.
Yes.
So
This is to an extent an epidemiologist's worst nightmare come true. A lot of movies like Contagion and others kind of saw this, but that was an imagination, and that was still a worse nightmare. Unfortunately, today it seems like in some parts of the world this is reality.
in terms of the pathways the virus take, where exactly does the virus attack in the human body once immediately after it gets inside?
So what we know, there's a lot about that we don't know about the virus, and so you have to keep that in mind, that we know very little and it'll take some time before we fully understand this. But from what we know today, the virus seems to attack the upper respiratory tract. That is the nasal passage, the throat, uh, and cells that are involved that line the upper respiratory tract. Now, the virus has a particular protein called the spike glycoprotein, which is very unique to the SARS-CoV-2 virus. And
So
this is
this
the
must be
kind of
found even in the previous SARS
yes,
virus.
this was also found in the previous SARS virus, and that's why they actually used the same kind of mechanisms to enter the cell. So this particular glycoprotein looks for targets, other protein targets on the cell, and there are a couple of them that have been identified now. The most common being the protein called as it's an enzyme called as ACE2, and so this virus protein binds to the ACE2 receptor, and then it's taken up by the cell in a manner in which a lot of other nutrients are also taken in. So the cell doesn't really know that this is a virus. It's kind of letting it in without knowing that it's a virus. And when the cell is infected, the virus starts multiplying inside the cell.
So, I'm just curious here in the sense like there are some similar. It comes under the SARS family, right? The
Yes,
coronavirus. But
yes,
if I'm not mistaken, we do have a cure for the SARS virus, like the one which infected us back in 2004.
yes.
Does that not apply to the coronavirus in any sense whatsoever?
Not really. So the vaccine. So what you're really talking about is vaccine. It's not really a cure, but the vaccine was developed with the idea that it would stop the replication of the virus. It would stop the virus from dividing, and that would then make it less harmful to the human body. Now, this was a specific piece of RNA that was found in the SARS virus, the SARS original SARS virus. And the coronavirus that we have today, which is the SARS-CoV-2, has a different piece of mRNA. So the vaccine that was developed for that particular virus, for the SARS virus, is not as effective on the SARS-CoV-2 as it is on the SARS. Having said that, a lot of the antiviral therapies and the drugs that were developed and that continue to be developed for SARS are also being tried out on SARS-CoV-2 with this exact same idea that if they worked on SARS and it's a related virus, there's a very high possibility that they would work. The one that is currently in the news, remdesivir, was also tried. Initially, it was developed for Ebola, and then when SARS came, they've tried this as well. Now, what we have to realize is that this is still at this stage, because it's so early, we don't really know necessarily if these drugs work or not. But there is definitely the hope that the drugs will work, and it is only a matter of time when the clinical trials are over and we had time to really analyze and interpret all the data, will we know that whether these drugs worked or not and which one worked better than the others.
So is that the same case with hydroxychloroquine, and is that the same case with that? Because a lot of countries have now, bought a lot of hydroxychloroquine, India being one of the
Yes,
biggest producers amongst them. So
yes.
that
So,
seems to be a miracle drug for a short time, and then all of a sudden people realize, no, this does not work for everybody. What is the
so,
story
so, so
behind that?
this is not unusual. A lot of drugs have gone through this trajectory. And one way of really, you have to realize that this is an emergency. The situation that we're in today is such an unusual situation. And so a lot of rules that apply under normal conditions can't be applied in an emergency. So there was anecdotal evidence that hydroxychloroquine works. And if you're a physician, if you're a doctor treating a patient, then you really have run out of choices. And your first and foremost job is to save the patient. And at that point, you're willing to try anything that is even remotely possible or feasible. And the Hippocrates Oath actually permits a doctor to do that. Even if you have no evidence that a drug works, if you, in your best judgment, best professional judgment, if you think that this might work, you have the license to try it out to save the patient's life. Right? And so there was a lot of anecdotal evidence accumulating saying that hydroxychloroquine seems to work. Now, there hasn't been a trial that is completed yet, and we really have no scientific evidence that it works. And even the American president who most famously endorsed it, and after which it became really popular, was advised by his task force and by the health professionals that there is no real evidence at the moment that it works very well. That doesn't mean we should not use it. That doesn't mean that we should be using it on every COVID-19 patient either. And so I think this really sparked a scramble to get it, because the other thing, remember, is that most of the Western countries, the developed countries, Europe and the United States, have not seen malaria for a while. And malaria is very uncommon there. And especially since they also lie in the temperate to cold climatic zone. So malaria is a tropical disease. And so since they haven't seen malaria, there's no reason why they would be stockpiling. So suddenly you have an anti-malarial drug that shows some promise. And now you have a large number of patients. And if the physicians decide to use it, even on 10% of those, you really don't have the stock. And that's why there was this scramble to get it.
Well, you're saying that there's no proper statistical data. When true there isn't, but the crowd and everybody else is believing that this anecdotal data, or rather something which has worked maybe for some patients or even half of them, is the cure. So the immediate question in everybody's minds is, when is the lockdown going to end? Because we already have a cure.
Right. So it's interesting. Yesterday, I read a report about the current wonder drug that came in after hydroxychloroquine, which is remdesivir from Gilead Life Sciences. And there's a trial going on. There are a couple of trials going on, one in Europe, one in the US. And the very initial results of the trials have come through. And they don't look as promising as people thought they would. So it's not a wonder drug. It's not a miracle cure. Okay. Now this was reported, and Gilead stock fell about 8 to 10%. You know who reported this? Business Standard. What was the basis? So it was not a scientific journal or medical journal that reported this. This was reported by an economic weekly. The basis of their reporting was an abstract. Now remember, an abstract is only 250 words. It is nothing more than 250 words, which is less than half a page. So they saw a short report which was less than half a page, which was also leaked from the WHO offices. And so no one really knows whether it was part of a bigger report or the context of that. We don't really know that. So this was a leaked report. But in the era of 140 characters and sensational journalism, these kind of news tend to get caught very early. They tend to get amplified also very quickly in the realm of social media. And suddenly this starts doing the rounds of WhatsApp and Facebook. And this is the news portal for most people, which is why they think that the cure is there.
Being in that point, there's this rumor, or rather, I don't know if this is true or not, that a beer company in China engineered this to make sure the Corona beer sales fall down. That's why they named it the coronavirus. Now, how true is that, sir? Please say yes.
Well, I don't know how true that is, but Corona. I didn't think Corona was one of the top beer brands in the world. If it was Heineken, I would believe it. So both derive their name from the crown. So the Corona beer also, the logo has a crown, as well as the coronavirus, the spike glycoprotein, forms the crown. When I look at the genome sequence, and by the way, there are now more than 12,000 sequences available in shared public databases around the world of the virus. So a lot of people have looked at this, asking this specific question: has it been engineered? And when this happens, then we don't really, we would be able to see the evidence of that. So people have looked for evidence of engineering on the genome. We have isolates from Wuhan as well, which are the index isolates. There's a lot of data now looking at the virus as it spread throughout the whole world. And trust me, if one can sort of copy paste some genetic material to make the virus jump from bats to humans very quickly and dramatically, these copy pasting would be detected. I mean, it's a lot easier to detect this than photoshopped images, for example. Okay, or the kind of photoshopping that is done by professional models to make them look better and younger. This is a lot more simpler to detect than that. And so far, no one has found any evidence of this, which makes me uh, not believe that this was engineered or this was deliberate. Now, the origin is still a mystery, and they haven't really found an index case. But in many, many epidemics, it is extremely difficult to find the first case. It is not always possible. And in many epidemics, they have never found one. And so this is not
By
the only.
origin, you mean the species where it came from, or the
No, the
location?
first patient, the first
The first
patient.
patient. Okay.
Who was the first patient? So they know who was the first patient who was on record, okay, who was admitted and recorded as a COVID-19 patient. But was he or she really the first patient? And to give you a parallel of that, now in the US, we know that the first patient was not in the old age home in Seattle. The
Yeah,
first patient now was earlier,
yeah.
right? And so
In
initially they
February, if
found
I'm not mistaken. I just read this report
in
yesterday.
end of January, actually. They said
Okay.
that somebody who died in end of January, at that time they did not think that this person could have died due to COVID. But now when they went back and exhumed the body and looked at, uh, did the test, they found that this person and the symptoms were very similar. And so initially the first patient was thought to be uh, at an old age home in Seattle, but now they know that it's somebody else. And this was a person who came from Wuhan, who probably didn't have at least any known direct connection to this old age home. So they also got it via someone. So it's very difficult to trace the first patient. I mean, there's some very nifty detective work, and I think this is kind of more, to me, it's more interesting than CID.
Well, staying on topic with in how it's gotten infected, how it's gotten so far. I'm glad to know at least some reports from countries like Spain and Italy, which have seen the worst part of it in the early stages, have now started to decline. And even in New York, which is the worst hit place in America, started to slightly decline. So India has not reached that place yet. Yet still, I'm pretty sure in the incline stage, and cases are increasing day by day. Even close to my house, they started to come up right now. I can just hope that it's not the same for you over there. But from what I understand, like yeah, the worst will pass after the few weeks in every country, and but now scientists are saying that there could be a second wave during
Mhm.
the by the end of the year. Now, how far is that true, and is there any evidence to substantiate that why there would be a second wave?
Yeah, so again, it's hard to get evidence because we're so early on during the infection stage, during the pandemic. And so evidence only comes once you had time to examine it. But the idea of a second wave comes from a couple of observations. The first and foremost is that in certain countries like Korea and Singapore, where they had managed to get it under control rather quickly and very effectively, the second wave came. And even in China now, they reported 0 cases for a couple of days. And again, the case number has started increasing, mainly from people who had traveled outside the country and came back, or who were staying outside the country and have come back. And so that is one second wave where this could be immediate. I mean, Singapore is a good example. There was a outbreak in one of the worker dormitories. And since this is a confined space with a high population density, it spread very quickly. And the government decided to test every worker in the dormitory. And so suddenly the number of cases has gone up from 3 to 4,000 to now over 12,000 in a matter of days, right? So that is one second wave. The other second wave comes from the fact that if you look at other viral infections like influenza, like polio, it was always seasonal. So right now actually is also the influenza season. It's the beginning. Spring is the influenza season in the US. And I was very, very surprised to know when I went to the US for the first time and I heard that people die of flu. Okay. In India, we never believed it. I mean, you have a flu, you take some crocin or go to the doctor, he gives you a couple of pills, stay at home for 3 days and you're fine.
Yeah.
Yeah, and so we never imagined that people could die. But when I went to the US, for the first time I heard that people are dying of flu. So this is also very seasonal, and that's a good number. Actually, currently number of people deaths from COVID-19, around 50,000 in the US, is roughly in the same range as what 20 to 50,000 people die every year of flu in the US. So it's not that worse. The only difference is that these have died in a very short amount of time. So flu season lasts for a couple of months, whereas it's been hardly a month and these deaths have occurred. So that's the difference. But that's why people feel that if it's a virus, then and if it behaves like flu, it could come back. It would come back the next winter. But the temperature association or correlation between temperature and the virus has still to be proven. And if you look at places like Ahmedabad, I mean, right now, Ahmedabad has already reached 40 to 42 degrees Celsius in the afternoon. So it's pretty hot in the afternoon in summer. And the virus doesn't seem to care about it. I mean, today we see that I think Ahmedabad will probably, if it has not already, overtake Delhi in terms of number of infections. So we're only second to Mumbai. And, it's very hot, but still the virus continues to spread, to infect. And so this temperature correlation is still not proven.
But I at least hope that we'll be much more prepared for the second wave, because from what I read recently, apparently Oxford or Harvard, if I'm not mistaken, they're trying out for human trials in terms of a vaccine.
That's Oxford, yeah. Oxford is
Right?
doing a
Yeah.
vaccine, yes.
So how far would you think that would be successful? Because from what I understand, they have done it in a pretty fast pace, like getting a vaccine.
Yes. So this is a question that is on everyone's mind. When will we have the vaccine? Uh, Now, the Oxford trial seems to be promising because the group that is doing it has a lot of experience with vaccines, with viral vaccines. They're actually expressing the protein, or they're trying to have a similar virus, not the SARS-CoV-2, but a related virus where the surface proteins can be expressed and injected. What is being really fast-tracked is not the science, but the administration and the regulatory process, which many a times is actually much, much, much slower than the science. It takes longer to get regulatory approvals. So all that has been cut down. In fact, it has been cut down to the extent where they have contracted the Serum Institute in Pune to start manufacturing doses of this vaccine. And so in the limited trial, so the first question you always ask is safety, and this trial is being carried out in the UK and by Oxford, researchers from Oxford University. So if they are successful in this, and they want to now go for a larger multi-centric trial across the country or across different countries, then they would be ready for it. So they've contracted Serum Institute to have enough doses ready, assuming it will work. But we have to realize, and especially as scientists who are trained in skeptical thinking, we are always skeptical. And so we have to realize that there's a big if in all this. And this is the if that no one wants to talk about. And already I see people assigning percentage of success. There's an 80% chance that they will succeed. I don't know where this 80% chance came from. I read this in one of our newspapers yesterday, that researchers give it an 80% chance of success. We all hope that it succeeds. Everyone is praying that it succeeds. And the trial is being done in the hope that it will be successful. But we also know that a very small proportion of vaccines, drugs, and therapeutics actually succeed in the clinic. Most of them don't. And so there is a big if, that if this is successful. Now, this is just one trial. There are other trials that are happening. There's one happening in the US. There's a company in Germany that's doing a vaccine trial. So a lot of trials are happening worldwide. Now, the encouraging thing in all this is that I think the scientific establishment is moving as one unit with an efficiency that we've never seen before. So the speed at which all of this is happening is truly amazing. And so most of us hope that with all these efforts that we're putting in, we would have a functional vaccine before the next season, when we will be better prepared for it.
That's actually great news. Some of the best news I've heard so far. And And you, sir, I know as well, like you are working towards doing something in this area yourself. I know
Right.
virology isn't your, at the topmost priorities on a normal day, but today I see every scientist is trying to contribute in their own way to it. So if you could
Yeah.
tell us about what you're doing and how that impacts.
Yeah. So when this pandemic started, I think me and a whole lot of other people, including many of my friends in science, have always asked this question: what can we do about this? And so now you have to realize that we are not virologists. We don't necessarily have experience or training in virology. I do have a master's degree in microbiology, so I understand viruses a little bit, but it's been decades since I have not worked with any microbes. However, we have certain skills. We understand the biology of the system. We are able to look at the sequence data and interpret it. It doesn't matter whether it's for a human cell, an animal cell, or for a virus. We are also able to, we are exploring, for example, the host response. And so one of the ideas that I'm working on is how does the host respond to the virus? And can we measure this host response? How can we measure this host response? If we're able to measure this host response and understand that, then we may be able to better predict whether the drugs are working or not, for example. Or we may be able to better predict when the patient should be discharged from the hospital. Not only when it's PCR negative, right now, 24 hours, 2 PCR tests. But what if one of those tests was a false negative, right? And so that's really not the best way to decide when the patient should be discharged. The best way to decide is when you know that the patient's immune system has kicked in and is in a position to kick out the virus, is competent enough to kick out the virus. So these are some of the avenues that we're working on in trying to understand the host response to the virus, in trying to understand can we then develop better diagnostic assays or prognostic assays that can tell us exactly what's happening, and also asking simple questions like looking at this data that how is the virus mutating? Is it as bad as flu? So again, one of the bigger worries is that the influenza virus is one of the most mutating viruses to the point where a vaccine that we make today is useless a year from now. Okay, so if you see how the influenza vaccine is made, there's a worldwide network of centers that shares the sequence data. The same network is being used now for sharing the SARS-CoV-2 data. And this network keeps track of which are the 4 or 5 most common epitopes in that season. These are proteins, surface proteins on the virus in that season. And then this data is submitted to the WHO, to the CDC, and they decide, okay, for this year, we're going to make a vaccine that targets these 4 or 5 proteins. And then it goes ahead before the influenza season starts. All this has to be done before. So it's actually based on last year's virus data to a certain extent. But whatever we do this year is completely irrelevant next year because the virus has mutated, the proteins have changed. And so one question that everyone is asking is the SARS-CoV-2 similar? If it is, then it'll be a nightmare for us. But if it is similar to the SARS, the original SARS, there it does not mutate that fast, and that means the vaccine that we develop today could still be useful a couple of years. Or is it going to be something like chickenpox or measles? We get vaccinated against that when we are small babies, and then that immunity lasts us throughout our lifetime. So if it will be like this, it will be very good that everybody gets a vaccine and it becomes part of the vaccination protocol in every country, and then it gets eradicated because you get the immunity once and it lasts a lifetime. But all of these are questions that today we really don't have answers to, and but these are all interesting questions, and so a whole lot of us are trying to ask and understand these questions.
What I want to ask is, like, I know you've been in touch with a lot of scientists who are working in this day in and day out and who are actually at the core. So I want to ask you from your own expert opinions, like, do you think this virus will forever be like, like the flu, or will it finally go away? Can we beat this using some vaccine or even a drug for that matter?
So if you looked at history, history is a good guide to this. Many viruses have come. Some, like flu, have stayed. Some have gone, and we never heard about them. And Some, like Ebola, have gone and then come back in sporadic cases or in small pockets. And considering that the extent to which this has infected the population, the human population, and it is really a pandemic that has spread throughout, it is hard to believe that it will go away. But at the same time, it's really hard to predict a certain change in some parameter, a certain, maybe a 1 degree change in climate, or a change in our habits, or anything that we don't know today, that we can't foresee today, could wipe it away. But we can't depend on that. So the assumption that we make is that the virus is going to be here. I mean, look at SARS. It's been what, 17 years now?
Yeah,
16 to
almost like
17 years that SARS epidemic was ravaging through Southeast Asia. And while it has not gone away, it's still there. There are SARS cases. Even today, those numbers are really low. So we've learned to live with it. And I think this is what's going to happen for this virus as well. Because remember, we're also evolving. It is not only the virus. Our immune system evolves. And so there will be a point where we will learn to live with the virus, and it will be a part of our daily lives.
so it'll be like, yeah, I'm just gonna leave today. If I might get infected, not infected, who cares? It's just a coronavirus.
Exactly.
Hopefully, we get there someday. And well, sir, I guess that's it from my side for now. I would definitely look forward to coming back to you and interviewing more once we get some more progress in this area.
Sure.
But before you leave, I just have one question. Uh, I know this, and the people who study under you know this. You're a coffee expert. Like, you somehow know coffees from places where we've never even heard of before. Forget the coffee, you never even heard of the places. So, uh, why, or rather, how did you get to be such a coffee enthusiast? That's one thing I want to know before we leave today.
Okay, so that's an interesting story. So the person, I mean, my parents asked me the same question, by the way, because when I was a small kid, they made sure that I stayed away from tea and coffee. You know, most Indian households consider milk to the thing that kids should drink, and tea and coffee is a bad thing, like
Yeah.
along with a lot of other things, right? And so this really changed when I became a PhD student. And my PhD advisor, although he'd been in Mumbai for a very long time, originally hails from Karnataka. He's in Bangalore right now. And he hails from Karnataka, and he was a coffee. And this was the best time to catch him, because he was like, I'm looking after the department. I mean, if you ask my students, they really have to catch me. And I tell them that, don't wait that you will find time, that I may find time. Just come to my cabin and stand outside. And, if there's somebody, wait until the person goes and really catch me. So my advisor was also head of the division, and we used to have coffee together in the morning and evening. And this was really the best time to catch him. Now, in those days, the biosafety norms were not that strict, and so we actually were making. We could make coffee. You can't do that today. No laboratory safety officer would ever permit that. But those days, we were actually making brewing coffee in the lab, and this is where, as a PhD student, I got addicted to coffee. I got addicted to good coffee. So when I was writing my thesis, I would write on weekends because that's the quietest time, and we didn't have computers at home like we have now. So work from home was not possible. So I had to go to the lab and write, type it on a computer. Post lunch. Now imagine a good Sunday lunch. Your mother has lovingly fed you, and then you have to go and sit in front of a computer and write your PhD thesis. And
That's
not, that's tough. And it so happened that while I was in the state, uh, just 2 months before, one of my lab mates went to attend a cancer conference in Brazil. And she got me the strongest Brazilian coffee that she could find. And that really helped me get through my entire PhD days. And that is when I started drinking coffee seriously. And that has continued ever since.
we see that. So
So
anyway,
to the point where, I'm blamed that my kids have got into the habit of drinking coffee because of me.
that's actually a fun story, and I'd like to end the interview on a fun note. And thank you, sir, for giving us such insights into what's actually going on and how we can maybe combat this.
Yeah, thank you for having me on this show. And I hope we're able to get back to work soon. But until then, stay home, stay safe.
Thank you, sir. Thank you.